Well, hello, friends. Welcome back to browser hacking. Today, it's a week since we started working on the JavaScript engine, and I think we got it to the point where we could begin to integrate it with the browser in Serenity. So that's what we'll be doing today. We're going to do maybe something simple like an alert box in a script in an HTML file, and then also maybe something like get element by id. So I think we'll start by making a little test file. So just a little test like alert, and I have to write out a reasonably well-formed document or the parser will be mad at me. Something that we should probably fix at some point. There we go. Okay, so then let's just alert hello friends. So if we can make this page pop up a dialog in the Serenity browser, that would be really cool. So let's get to it. The first thing we'll need is a script element. So we'll just put that in the DOM. And actually, the script element is kind of similar to the style element, really, because it's like an HTML element that has a bunch of text in it. So let's just copy the style element and take it from there. Script element, and then we will just make sure that we add it to the build system. Script element, okay, where's that thing? Meta refresh. All right, so HTML script element. So first thing we'll do a little bit of search and replace here, very manual. And I think we're going to use to insert it into notification to know when to run the script. So just to keep things simple, basically when the parser inserts the script element into the document, we'll just execute the script at that point. So we'll accumulate all of the text inside of the script element and then pass it to the JavaScript parser and then run it. So maybe we'll do something like, maybe it doesn't have to be more complicated than this actually, for now. So we're going to skip over a lot of things right now. We're like, we're not going to do persistent, any kind of persistence between script invocations and stuff like that. We'll do that later. And I think this guy right here, we can just not override him. Yeah, simplifies things a little bit. Okay, so yeah. So what we do here, when we insert, this is called by the parser. So when the parser inserts the script element into the document, then we will walk all of the text children, text node children of the script element and just accumulate their contents in a string builder. And then we want to pass that to JavaScript parser. So we'll do something like source, call it maybe source, just like that. And then we need libjs parser. And that would be something like JS parser, JS lexer source dot parse program. I think that's how we get it. Okay. And then what we need to do next is we just need to, maybe we should call this first actually, give this thing a chance to run. So now we have a program that we can execute, but we don't have an interpreter. So I think, where do we store the interpreter? I guess we can keep it, we store it on the document for now. So it's a little bit weird, but we can put it there. So we'll have a document interpreter maybe. And let's make sure that he knows he has an interpreter, otherwise things are getting a bit weird. So we'll give document a JS interpreter. And we'll just we'll just store that in an own putter so we can create it on demand, because, you know, many pages don't have JS, so they don't need a JavaScript interpreter. But in case you do, we'll just have it do something like this. So if there's no interpreter, then JS make JS interpreter. JS interpreter. And I guess this is where we would create anything that we want on the global object. We would have to set that up here. So it would be something like global object. Oh, and let's grab the header for that. Global object. So we want to put a native function called alert on the global object, and it will just take a vector of JS value arguments, and it returns a JS value. Okay, and then what we do here is if arguments, or no, we'll do it this way, string builder. And then for each argument, we will just append it to the string builder. Or is that how that works even? Maybe we don't even need to do that. I think maybe we can just do the first argument. So we'll say if arguments size is less than 1, return JS, I don't know, undefined. I'm not going to look up what these things are supposed to return right now. This is the kind of stuff we can get back to at any time. So we'll just take the first argument, turn it into a string, and then show it in a message box, right? So we'll need libgui message box for this. So GUI message box show arguments 0 to string. Alert can be the title, and GUI message box type information. Let's say it's information, right? That's pretty cool. Okay, and this call here will block until you press the OK button. So after that, we can just return undefined, I guess. I think the return value doesn't really matter. But this just means that the alert function is now available in the global scope in any JavaScript that we execute with the document interpreter. So let's see, what the script element will do is call interpreter .run, and we just pass the program. And we don't have any arguments for him, we just want to run him. So something like that. It's extremely simple looking, actually. Could it be this simple? I'm forgetting to instantiate the script element. So a little bit of boilerplate here in our function that turns tag names into tag objects. This should be generated, but it's not generated yet. New HTML script element. Look how extremely generator friendly this looks. So I definitely forgot something. Here we go. I am using the wrong prototype for my Lambda script element. No, wait, this was in document. We were setting it up. So this guy right here, he also gets the interpreter passed to him in case he wants to, whatever you might want to use that for. If you want to allocate a JavaScript garbage collected object, you need to go through the heap, which you get to through the interpreter. So That's why we pass it along. Oh, a bunch of link failures. I guess a bunch of them now will require to link with libjs. Yeah, so we'll just put JS up front here. Does that work? That did not work. Okay, maybe I have to put it. This static linking orders is like, you just do it over and over until you get it right. JS. Okay, there we go. So it has to be in that order. Then we'll need to do the same with browser, and the same with the DevTools Hack Studio. Okay. And something else I'm forgetting, like the IRC client probably, because it actually uses libhtml, or not libhtml, libweb as it's now called. Libweb. Mainly because the namespace web looks nicer than namespace HTML. Okay. Oh, wait, so what's the fix for that? So put GUI after. Okay, fine, whatever. Oh, same problem in browser. Okay, this is very unexciting. So hopefully that should do it. And by the way, maybe you've noticed that I'm on a different computer. I'm actually working from home starting next week. So due to my employer wants us to take preventive measures against coronavirus. So they've asked everyone to work from home. So I brought my work computer home. And since it is has a slightly better CPU than my home computer, I'm just recording on my work computer, because why the heck not? They're very similar otherwise, but I have a slightly different setup as a result, because I had to redo everything, and we're trying something a little different, but mostly the same. Anyway, so can we run this thing? So what did we call it? Alert. Look at that. Now that's pretty cool. We just ran JavaScript in a HTML file. These quotes are weird. I guess the quotes come from the string literals, because it just captures like the whole literal, including the quotes. So what are you doing with that? You make it like this. Oh, yeah, okay, so we'll just say like if m value and let's see, wait, hold on. If m value is this and m value, I'm just going to hack it so that we can get around this. This will not be the proper solution, but it will be okay. If m value length at least 2 and return m value substring 1 m value length minus 2. All right, very hackish. JS and browser and sync and run. This computer definitely feels a little bit faster, and it has longer cables, so I could put it further away, which means that there's less noise from it coming into the microphone, so that's probably good. Wait, so alert. Right, no double quotes. That's downright perfect, isn't it? So let's commit that little token change there. Strip double quote characters from string literal tokens. This is very hackish, since I'm just going to make progress on something else. This is very hackish, yes. But let's see. So then we want to, I guess we can just I was thinking, like, should we put the interpreter somewhere other than the document? But I think we can put it on the document for now, and then later we'll have to think about maybe putting it at the frame level or something. But we don't really have a fleshed out concept of frames anyway, and we don't support multiple frames, and everything is so far away and confusing. So let's just go with the simple way of putting it on the document for now. So we'll put these, and we'll add that guy. And I think we'll also link him from the welcome page, just so that we have an easy way. Test alert, or alert test. Cool. Lib web. Add script element and run any JavaScript found inside. Let's see, parse script elements. Dispatch begins integrating libjs into libweb. For now, we'll document holds the JS interpreter for now, and it is created on demand when you first call document interpreter. This patch, we also add a simple alert function to the global object. Yeah, that's pretty neat. Okay, so I think something we should do later is we should have a different kind of global object that is provided when you create a script execution context in the browser. Then we create like a DOM window object, and we put all the alert and things like that on there, and sort of keep that separate from the bare bones libjs global object. But we don't have to mess with that now because I wanted to do get element by id. So let's do that. Base DOM, something like this. So what should this do? Head, body. Every time I write HTML in a video, people are always commenting, why are you doing it this way? Why are you doing it that way? Use my editor. This is how I do it, okay? So we'll make an element called foo, and then we'll make a script that does something like this: document.get element by ID foo alert e. So if we run this in Firefox, we get something like this. And basically, we want to get something similar in our browser. So we wanted to find that development. Let me just link it. So, oops, let's see, DOM, simple DOM, JS test. Now, okay, so this will get a bit trickier. So now we need, well, we need a document object, and it needs to be visible to us in the global object. So here, we need to put something called document, and it's going to be some kind of a wrapper object that gives you a JavaScript object that sort of wraps the DOM document object, or the object that we're actually in right now. So what we want to do is something like wrap, maybe with the heap, or wait, we are in interpreter, so minterpreter heap, and this, something like this, right? And then we want that to create sort of, okay, we're going to flesh out some classes for this. So let's see, libweb bindings. Okay, so we'll have a bindings thing, and in here, okay, why is spelling hard? We'll have something called a wrapper and a wrappable that you can inherit, and we'll get something like a node wrapper for the basic DOM node, and a document wrapper for documents. And maybe we'll start with those, and I think we'll add CPP files as well. Maybe not for wrapper, but for wrappable. Okay, so let's see. I'll put this up top. Wrappable. And node wrapper and document wrapper. Okay. So a wrapper, it's going to be some kind of GC allocated object that internally contains a wrappable. And let's see how we do this. So it's going to be a GC object, and we'll put it in the libweb namespace, in a sub namespace we call it bindings maybe, and maybe just a wrapper like this. Wrapper is a public JS object. And we'll keep a non-null ref footer to a wrappable. And wrappable. Okay. And okay, that's so fine so far. So then we need to return wrapper. Actually, I'm not sure we're ever going to instantiate this thing directly. So let's say that we don't. So we'll leave that one alone. And libweb forward. So let's add some stuff to the forwarding header here. node wrapper, document wrapper. All right, and then we just need non-null ref perturb. Okay, so I can't construct it like that, obviously. Rackable. Rackable. And I guess we can make it public, an accessor for the wrappable. So, okay, why are you acting so weird? Wrappable. Okay, wait, what the heck did I do there? All right. That looks pretty okay, because where are we going with this? We're going to the node wrapper. This is the object that you get when you actually instantiate a DOM node in the JavaScript context, or when you query document get element by ID. This is the object you're going to get back. Web bindings. So node wrapper is public wrapper, and this will have const char libweb bindings wrapper class we'll just call it node like this, because this is just how it will show up in the garbage collector logs and stuff, and it's fine for it to show up as node. So this guy can only be constructed from a node. And did I say explicit here? I forgot. All right. So for we'll put that out of line actually. Okay. And then we'll do something like node or Rackable. Does that make sense? I feel like maybe it does. Node wrapper. Oh, that looks kind of tidy when you put them together like that. Let's try that. Haven't been using a lot of nested namespaces, but this feels like it's gonna look a lot nicer if we do. So we're going with it. So here we want node wrapper node. And wait, what's wrong with that constructor? Exit wrap. Oh, right. So now we need to make node wrappable. So libweb bindings wrappable. So wrappable is our base class that we will make anybody who wants to be exposed to JavaScript can just inherit from bindings wrappable. And we need the bindings. Wait. Oh, I didn't define it yet or declare it yet. Okay, that's fine. We'll do that next. But yeah, so wrappable. Namespace web, namespace bindings. So what is a wrappable? It's something that can be wrapped, and it will have a wrapper inside it, so that if if you sort of query the document get element by ID twice in a row for the same element, we'll give you back the same node wrapper both times. We're not going to instantiate two separate objects. We'll cache the one we give you the first time, and then you'll get that if you ask again. So every wrappable will have a weak pointer to its wrapper. And for that, we will need forwarding headers and weak putter. Okay. And I guess we'll have something like set wrapper, something like this, and also should take a wrapper amp actually. Wrapper. Something like that, and then we're all good. So I think we need to see the declaration of the DOM node here. Yes. Okay. That is cool. All right, and then we just need to implement those overrides. Rackable. So these are just some helpers that we're going to be using. So there we go. And let's put some property on this guy. So like, what's a good property? Like the node type or something like that, or like node. Why is it so hard? DOM node API. Node name. Perfect. Let's do that. So since that doesn't change, then we don't have to feel bad about not being able to return a different thing in the future. Since this is not going to change, as long as it's the same node inside the wrapper, it's not going to have a different node name. Right? I think. Anyway. So we'll just put the node dot tag name, I guess, as a JS string, where we have to pass the heap to allocate it. We don't have JS string, maybe. Per libjs primitive string. It's incomplete. We also need JS value. Man, we are pretty good at using the forward declarations here. You can tell because it's like, you don't have the declaration of that, just a forward declaration. It's nice actually. I like that because it keeps compile times a little more reasonable. So I guess we can actually modify our little test to show the node name. DOM alert e. Maybe we can, let's just say e.node name. That would be super cool if that could work. But before any of that can work, we need to get element by ID. So we need the document wrapper, which is what we'll be instantiating when you ask for a global document. So I guess it's kind of similar to node wrapper actually, and document wrapper should just inherit from node wrapper. So we'll say document wrapper is a node wrapper, and much the same concept here. We'll just make these guys, and it's pretty straightforward. And then in node wrapper we'll copy him to document wrapper as well. Just wildly copy pasting here. But yeah, no need to feel bad about that. Sometimes copy pasting is necessary. So I guess we need to include document wrapper. And we need document.h, and then we can just do a bunch of replace. Alright, so look at us with our fancy document wrapper. Step number X is going to be implementing getElementById. So this will have any properties that we added in the node wrapper constructor. So already a document wrapper in JavaScript will have node name. But we should also, actually we could test that, I guess, before we get too far here. So we could do something like alert document node name. So how would this work? Where did we create the document? We have not invented the wrap function yet. We just named it, but we need to actually, it needs to actually exist. So, should we put this here maybe? Something like inline wrapper wrap. Then we take a JS heap and a native object of some type. So template class native object. Seems like we need the JS heap here. Okay, so or no, it doesn't need to be native object. It just needs to be a wrappable. Although I guess we have to assume that it is wrappable because we're going to treat it like a wrappable now. So if native object dot wrapper, if it doesn't have a wrapper, then native object set wrapper heap allocate. How do we know what wrapper type to allocate? Native object wrapper type. And we'll pass in the native object. And then we will just return the native object wrapper. Okay. There's no conversion here because it returns wrapper. Wait. Do we know what a wrapper is? It's forward declared. Do we know what a wrapper is here? So I guess we need to create document wrapper in this case. So bindings document wrapper. Right. But how does it know? Wait, wrapper.h. So what did we forget? Rackable has no member named ref. Right. So I guess we could wrappable ref, something like this. deref and no, it's not called deref, it's called unref. And then on node, which is Rackable, we'll just unref. Something like that. Or they need to be, actually, they need to be called ref and unref for this to work. Okay, I'm getting a little tripped up here by the reference counting system, because it expects to find things called ref and unref on anything that you want to store in a non-null ref putter. So I'm just adding a quick mechanism here so that you can override. Since I don't want Rackable to be reference counted itself, it's just going to forward the reference counting requests. So we'll do it this way. Unref, Rackable, unref. Okay. And then it will be up to whoever inherits from Rackable to implement these things. And I guess we'll need something like that. Or not override. Unref is ambiguous. I guess it would be tree node, tree node, unref. Oh, I don't love this. Okay, maybe we don't do it this way at all. Maybe, maybe. I guess we can make it up to the subclass to deal with this. Then we don't have to screw with the ref counting. Okay, so we'll have these virtual APIs, wrapper, and set wrapper. That's enough. And then in the node wrapper, we'll store it here. So non-null ref putter to node and node. And it kind of simplifies that a little bit, actually. And wait, what am I even doing? This was not the problem. I'm in the wrong place thinking about the wrong stuff here. What the heck am I doing? I want to go in the wrapper class. And change the wrapper class so that he doesn't store a wrappable. But instead, he stores nothing. Yeah. And then you have to inherit from this guy, and then it's up to you to provide the storage. That makes a lot more sense, because then we don't have to care about that anywhere. So node wrapper, yeah, sorry about that. I got totally confused there. So the wrapper doesn't need the node anymore. It can just be implicitly constructed there, and instead we'll just store it like this. That actually removes the need for these functions. So big benefits. Instead we can just have node, return a node, and a const variant like that. That's actually way nicer. Document wrapper, so he can just say, we'll call it node here as well. I think maybe let's just be a more strongly typed variant of it. So okay. There we go. That's more tidy. So now node wrapper has his correctly typed native object stored here, and then wrapper is just a very thin thing that you inherit from, so that we get a uniform interface. Wrapper type is not a member of document. Oh yeah, right. So I wanted to use some kind of type def or something to figure out which wrapper to allocate. So for document, I think we'll do something like this, like using wrapper type is bindings document wrapper. Will that work? I guess we have to say type name actually. So we have to say type name. Cannot convert document wrapper to a wrapper. What if I star it? Okay, we are compiling at last. So it would be cool if we could actually call document.nodename. I think this will work. I feel like the pieces are in place. Of course, we don't have a story for garbage collection at the moment, but we can't do everything at the same time. And we'll need to rebuild the web. And we need to implement some more functions, it seems like. So namespace web, namespace bindings, Rackable. What else was in that one? Set wrapper? Yeah, set wrapper. Rackable set wrapper. All right. So this is pretty easy. M wrapper is wrapper make weak footer. Wrapper, and it's not weakable. So we make it weakable. Public weakable wrapper. Yeah, I think that'll be okay for now. So in the future, we might want to integrate like weak pointers or weak references with the garbage collector and make like a specialized version of it for GC objects. But right now, we can just use the regular act weakable template. The issue with this one is that it relies on the presence of a destructor. And then in the future, we might want to get rid of destructors for some objects to make garbage collection faster. But we're pretty far from there, so let's not worry about that right now. Maybe we should check that there is no wrapper already set, because that would be a bit weird. Okay. Look at that. Is that not the document tag name? It is indeed the document tag name. Shit, that's pretty nice. So, all right. I think let's try to commit this before we go forward with get element by ID. So it's actually nice that we had a stopping point here. So bindings, and we'll add that guy, and let's say libwet. Add start implementing basic DOM bindings for JavaScript. Basic JavaScript DOM bindings. Yeah. This patch introduces the wrapper and Rackable classes. Node now inherits from Rackable, which means that and can be wrapped in a node GC allocated bindings node wrapper object. The only property we expose right now is the very simple node dot node name. Node name property. And I'm probably not even exposing it correctly, but it is a start. Or actually, let's see what would happen if we would open it. Home unknown DOM. Oh, actually, it is showing up the same way in Firefox. Cool. This is pretty cool. I do think this is pretty cool. When a document's JS interpreter is first instantiated, we add a document wrapper for the document property with a document wrapper object to the global object. Yeah. Cool. So let's do get element by ID. So in document wrapper, here we can just add whatever things we like to the document object, basically. So we'll put a native function, call it get element by ID, and it will take the interpreter. So let's not forget it this time, and a vector of value, JS value, which are the arguments. And of course, we have to return a JS value. So in this case, we just have the one argument, which is going to be the ID we're looking for. So if arguments is empty, return, I'm not going to look up what's the correct thing, so we'll just say null, whatever. Maybe we're supposed to throw or something. We'll figure that out some other time. But we'll say ID is the arguments 0 to string, and then the element is document, node, get element by ID. Oh, I don't have this captured. Oh, we can just capture this. Get element by ID, ID. Okay, now we have the element. So if we don't find anything, then just return JS null, I guess. But if we do find something, we need to wrap this in a, I guess in a node wrapper for now. Since we don't have an element wrapper, we can make a node wrapper. So return wrap. This is the part where we need the interpreter. interpreter. Oh, actually, maybe we don't need the interpreter. Can we just call heap like this? Maybe we can. And just pass it the element. What will happen? I feel like it's not going to find the node, the wrapper type. Incomplete type, right, so it doesn't find the wrapper type. Element. Can't convert. Wait. Yeah, there's no wrapper type. Okay, so since we don't have an element wrapper yet, but we have a node wrapper, so we'll just go here to the node class and say using wrapper type is findings node wrapper. No? Const qualifier discarded. Well, I'm sorry. We'll just do this for now. I think probably get element by ID does not return a mutable pointer. Yeah, so you know we can do something about that later. But please compile. That would be so nice if you compiled. Okay. Oh, it's whining about something I did here. Hex Studio. Oh, I guess I screwed up the makefile a little bit. Dev tools, Hack Studio, makefile, JS. See, we have JS twice. That's my bad. Maybe we didn't need that then. Okay. Let me just fix that right away. Fix Hex Studio makefile. Oh, we're gonna squash that, don't worry. Okay, so let's edit our test program. DOM. So now we won't just alert the document node name, but we'll search for the element and see if we can alert that node name. Wouldn't it be nice if this just worked on the first try? Come on now. Pooh. Look at that. Very neat. Yeah, and then the page opens, of course, because we are running the script like in a callback from the parser. So that's why you see the alert before we actually transition to the new page. It's a little visually strange. Maybe we should do something about that, but you don't have to do it right now. This is really cool though. Okay, so super duper straightforward actually. Very like. Okay. Oh, I have to sneeze. Sorry about that. Let's just commit this. So libweb add expose add document get element by ID to document wrapper or implement. This was, I have to say, pleasantly simple. We don't have an element wrapper yet, so this So it just returns a node wrapper, but it still basically works. Fascinating. So let's take that guy and just, let's just reorganize here a little bit. So 5 or something. I guess this guy goes here, right? Squash. Wait, am I choosing the right thing now? Yes, that's the right one. Okay. And Hack Studio, it's not even touched anymore. All right. Let's just make sure that we're building everything correctly. But this, I would say this is going really well. So I'm really happy with this. And I think probably we're going to wrap up the video here. We're just going to take one last look at it. But yeah, it was extremely straightforward to get basic script support in the browser, right? Now that we have all the right building blocks in the libjs. So super cool. This will be the end of the video, like I said. So if you made it this far, I thank you for watching, for hanging out. And I hope you saw something interesting. And I certainly had an interesting time bringing this up. Because, you know, I kind of had an idea of how to do it, but to see the idea through is such a nice experience. So I'm glad we were all here for that. Anyway, I guess I'll see you next time.